this is Captain Chaudhari. Today I'm going to do a calculation on severe wind criteria. We've already done the theory on severe wind criteria. This is an additional criteria that is to be satisfied by a cargo ship and a passenger ship. Let's do a numerical from my book, that is Basic Stability Calculations. The question is MV alpha ship is on even keel draft of 9 meter kg 7.96. Free surface correction is 0.1, FSC is 0.1. Area, that is windage area, side windage area is 2780 meters square. That is the windage area. Center of windage is 8.8 meters above the water level. K is equal to 1. 8.8 meter with respect to water level. K is equal to 1. The ship has no bilge keels, right? Hydrostatic draft considered as molded draft. So molded breadth is 24 meters, CB 0.78. CB is equal to 0.78. Length at waterline is 179 meters. Angle of flooding is 42 degrees. Now we need to find out whether the ship would satisfy the severe wind criteria. Now what we have to do basically is we have to make a GZ curve of statical stability, GZ curve. And for making the curve, that is GZ curve, we need to pick up Kn values from the table. As you know, the hydrostatic tables, they give you Kn values. And Kn minus kg fluid sine theta gives you the writing given. So let us say that you have already done this exercise of finding out Kn values from the tables earlier, and therefore directly let us put the GZ values for the different angles. So GZ I would write for 5 degrees, 10 degrees, 15 degrees. GZ values for 5 degrees, 10 degrees, 15 degrees, 20 degrees, 25 degrees, 30 degrees, 40 degrees and 45 degrees. I will directly write the GZ values 0.215, 0.428, 0.215, 0.428, 0.607, 0.777, 0.842, 1.052, 1.204 and 1.118. So these are the values of GZ. We need to make the curve first with these values. So let us say I will approximately draw this curve and 45 degrees. For 5 degrees we have 0.215. For 10 degrees we have 0.428, 15.607. For 20 it is 0.777. For 25, 0.842. 30 degrees is 1. 40 degrees is 1.2. And 45 degrees 1.118. So if we draw the curve would appear like this. We need to draw the mirror inverted image on the other side. Mirror inverted means first left to right and then top to bottom. So let me try to do the mirror inverted image of the curve. Now we need to find out LW1. LW1 is equal to PAZ upon 1000 G 1000 G delta. Now P is 504 newtons per meters square. A is the windage area that is given as 2780. and Z is the vertical distance between. Now suppose here's the ship, this is the waterline, this is the center of buoyancy, and the average average center of windage is how many meters above the water level? 8.8 meters above the water level. Draft is 9 meters, so we know that this is 9 meters. KV is 4.782, which means that from center of buoyancy till the keel is 4.782. So 9 minus 4.782 will give me this distance. So 9 minus 4.782 gives me 4.218, and 4.218 plus 8.8 gives me 13.018. That means from center of buoyancy till the center of windage, the distance is 13.018. So that is the value of Z. So Z is 13.018 divided by 1000. The value of G is 9.81, and displacement of the ship is 26,672. 26,672. That is the displacement of the vessel. So I have got PAZ divided by 1000 G delta. Let me see, 504 into 2780 into 13.018 equals divided by 9.81. Gives me LW1 as 0.0697. So that is as good as 0.07 meters. That is LW1. And LW2 will be equal to this value multiplied by 1.5. This is 1.5 times LW1. So that makes it 0.105. 0.105 meters. So we have LW1 calculated with PAZ divided by 1000 G delta as 0.07 meters, and LW2, which is 1.5 times LW1, is 0.105 meters. Now I will draw a horizontal line showing LW1, that is steady wind heel lever. Steady wind heel lever is 0.07 LW1. So I'll draw a line from here, that is LW1, where it cuts the GZ curve. This gives me the angle of heel, which I would say is, let's take it as 2 degrees. Now this 2 degrees is well within the limits, because this angle is supposed to be lesser than the smaller of 16 degrees or 80% of deckage immersion. So we have no problem about the steady wind heel. Now 0.105 would be something like this, 1.5 times, but this particular line has to be extended on both the sides. Somewhere on the right side, this is, by the way, leeward side, and this is windward side. On the leeward side somewhere it will cut the GZ curve. We don't know, it is way beyond 45 degrees, or it is even beyond 50 degrees, looks like. Here the boundary is like angle of flooding, which is 42 degrees or 52 or 50 degrees, or second intercept. This particular cutting is called second intercept. So the smaller of all the three is 42 degrees. So at 42 degrees I have the limit over here. Now this line that is drawn, that is LW2, is a pivot point line. Like this is the pivot point about which the area A on the windward side and area B on the leeward side, they pivot. Now extending it over here, this is the second intercept, and this is the area we are talking about, would be called area B. Now on this side also I will extend this line LW2, right? And then I need to find out one more thing, that is 109 K x1 x2 under root RS. So how do we find these values? So for finding out these individual things like x1, x2, I need to have a special table. So there are 4 tables, right? You can see in the hydrostatic tables they are given. Table 1 is dependent on the ratio of molded breadth and molded draft, and the value that is obtained is called x1. Now what is our molded breadth here? Molded breadth is 24 meters, and what is the molded draft? It is to be taken as 9 meters. So 24 upon 9. 24 upon 9, 2.67. So if it is 2.67, I would say 0.95 can be taken as x1. So x1 is 0.95. About x2, which depends on the block coefficient. Now the block coefficient given in the question is 0.78. So if we look at 0.78, it is more than 0.70. So table says if it is more than 0.70, it can be taken as 1. So x2 will be taken as 1. Now K, there is no bilge scale on the ship. It is stated that there is no bilge scale on the ship. So if we look at table 3, table 3 says that the area of the bilge scales, that is AK multiplied by 100 divided by length into breadth, gives you the value of K. If there is no bilge scale, we can take the value of K as 1, right? So once again, K is 1. Now under root RS, what is R? R is given by 0.73 plus minus 0.6 into OG divided by draft. So we have OG, that is the distance between the center of gravity and the water level. So in this question kg is 7.96 meters and the draft is 9 meters. So the distance between the water level and the center of gravity is 1.04 meters. Yes, it is 1.04 meters. Now the center of gravity is underwater because kg is less than the draft of the vessel. So since the center of gravity is underwater, we will take minus instead of plus. So it will be minus 0.6 into 1.04 divided by 9.73 minus so much. That is the value of R. Let's find this. 0.6 into 1.04 equal divided by 9 gives me 0.661. 0.661 is the value of R. Now let us find out the value of S, which is to be found out from the table 4. Now table 4 says that S depends on the periodic time of the vessel, which is calculated by a formula. Formula for finding out the periodic time is T is equal to 2 CB divided by under root GM. So what is C? C is given by another formula. C is given by the formula 0.373 plus 0.023 into B upon D minus 0.043 L upon 100. So as you know, the theta 1 value is calculated from this formula. Theta 1 is equal to 109 K x1 x2 under root RS. And I've told you this, there is no bilge scale, so K will be 1. K is found from table 3. X1 is found from table 1. And x2 is found from table 2. Under root RS, R is found by 0.73 plus minus 0.6 into OG upon D, right? I have put a minus sign here because the center of gravity is below the water level. If it was above the water level, I would have put plus. Now S is to be found from the table 4 depending on the value of T, and the formula for T is 2 CB upon under root GM. I assume that these values are found out by you, and when I get theta 1, suppose theta 1 is 21 degrees. So 21 degrees is not to be measured from the y-axis. 21 degrees is to be measured from this vertical line, which was drawn at the intersection of LW1 and the curve. So suppose the steady wind heel angle was 2 degrees, then 21 degrees will be measured from here. That means from y-axis the distance will be not 21, it will be 19 degrees. Now this is area A. You can see the horizontal and vertical extension of these curves, area A, area B. Area A must be less than area B. B should be more than or equal to area A. B is the area on the leeward side, A is the area on the windward side. You can actually do the calculations by Simpsons to prove that area B is more than area A, but here in this diagram it can be seen directly that area B is more than area A. That is the calculation that is done for proving the satisfaction or demonstrating the satisfaction with severe wind criteria.